Lastly, we will explain the database. It efficiently records both time series sensor data and behavior data. The database is made up of high-speed processing system that can be used for various purposes. Here, we will explain how the system is used from point of view of the patient. The blood pressure sensors are compact and can be easily fitted by patients themselves. The pulse width measuring device is attached to the ear, and the electrocardiograph is attached to the chest. Both devices transmit data wirelessly to the receiver. Conventionally, it has been difficult to measure blood pressure while a patient is moving, but with this system, measurements can be made even in mobile conditions. The patient can take note of special types of activities during measurement, such as climbing stairs or taking a rest. Measurements continue to be made even as the patient performs activities, such as climbing stairs, so that blood pressure changes during movement can be tracked. We asked a test user regarding what he thinks are the merits of the system. He noted that the device is more comfortable compared to the conventional ones, and enables better understanding of your own blood pressure characteristics, enhancing awareness for your own health. However, activities automatically recording feature and improvements in the feedback would be better.
Okay, this is the first topic. And the second topic is the stress. So, in order to grab the stress condition, you have to also measure something what your output in continuous way. And then in the research or experiments, maybe applying some attending some kind of arithmetic task or memory task. That is not the actually it is a narrow meaning to that stories. But what we are talking is the social the stress problems in the social. So those are coming from the human relationship or career path or kind of. So in order to catch those things, we also need a continuous method, monitoring method. So in this case, we put the 6 pressure sensor backside of the patient. And then all the students in our laboratory should take these questions for 2 weeks. And then you can imagine that the final examination or mid examinations or the talking with the professor, so many stressful events are happening, and then plus the monitoring from this system are combined together to observe what's happening. Okay, so this is the mechanical engineering point of view, not accepted, but it's okay. Okay, so it's very simple. We have same pressure sensor attached to the outside cushion, and then when the person is sitting, we can monitor the change of the posture or catching some kind of behaviors during the working, just working. Sort of things are option. Very, very simple, but very useful. Okay. And then, so we extract the 4 features. So it's something like the, okay. So this is kind of a very small frequent motion, something like this. So this is the very big motion, right? The last, this one is the short, sudden change of the sitting movement. Those things are the focus or observed when the participants feel the stress. And then we check the timing of the each motions, and we also check the interval between motion. Okay, so the so many things are shown on this one, but the important thing is that if we are focusing on some level, it means some the behavior, we can know the chronic stress or without chronic. So in this case, it also this case is no. And then like one is the same level, but that could be some cases the chronic storage, big values here, but some participant cases no without chronic storage, I mean the chronic storage free case is a big value. So the how to say the behavior is different from the past, but if we know the type of the persons, we can monitor chronic stress conditions with this. Okay, the third one is not sensing, but we are doing some research how to evaluate the performance, especially cognitive performance. I mean, working performance, but very difficult to check it. So if you can use some kind of a task kind of that, easy to evaluate quantitative. But during the usual working, difficult to measure the situation. So this is just the interface, how to evaluate sort of things. The point is that we prepare in application the three types of cognitive performance tests plus wearable sensors, something like a Fitbit or Apple Watch kind of that, to get the physiological data. They combine together, especially these three parts are connecting to the model of cognitive the computer models. So in this case, we are using the after but it is very famous the model in that area. And then we estimate some of values in that model by using the physical data. So this is the first layer in that area combined with physical data and then cognitive model. So in order to the useful data, we have to encourage the participants to continue this to use this application. So how to motivate the participant to use this? That is the point, right? So we prepare the four types of encouraging behavior design. The monetary motivation, yes. Second, self-control motivation. Third one is social motivation. Last one is action reward system. And then finally we got this kind of data. So that part would be three type of cognitive performance test arch. So looking at this one, many of users are achieved could continue the three types of the cognitive performance test using this. So because the ranking motivation, reward motivation is very effective to continue use this. So maybe this the findings is very useful when we not only this kind of application but other application should include this kind of engagement design. So actually, we have so many the wearable sensors and with some applications. But maybe the first stages, maybe you can check frequently these devices and applications. But after 1 month, 6 months, I don't know. But they're only just wear. Right? So this is not good. So this kind of engaging feature should be designed in application. Can you understand me? Okay. This is kind of a human center. Okay, so having this sensing technique, we have started the cross-modal sensation for feedback or intervention. So recently we are focusing on the window sensation. So how to change the window condition, how to reproduce the new experience of window sensation. That's it. So the window sensation displays are researched so much by so many researchers. So this one is the so many fans are installed in order to control the strength of the window or direction of the winds, right? But this is very actually very clear to useful to show those of things, but how do you say? Can you put it in your rooms? Can you carry this system? No. Okay. So instead, there are some researchers this kind of compact, rare, so window display, but very big. So in some cases that is useful. So another top the researchers propose the window temperature. Maybe there's some fun and some creative elements combined together to make the warm window or cold window. Okay. And then, so this slide shows the relationship between the window sensation and the sensor. When you feel wind, so what kind of stimulation there come to you? So wind source, if someone here we can hear the sound of the fan, so we can notice the window will be coming from, right? And then if the fan is rotating outside there, here maybe we can recognize it by vision, right? So accordingly, this so window interactions, maybe swaying of branches, trees, or window noises, and visual. The wind feeling, skin vibration, the wind pressure, maybe you can feel such stimulation when you feel the wind. Okay? And then the window induced temperature changes also recognized by you, the cooling or hearing. Here the very cold is but you can feel. So if this kind of a stimulation, sensory stimulation, are reintegrated, you can feel wind sensation. That is the research question. Okay. And then what is the application, right? So this is just the announcement. So we have oh, sorry for this one. Sorry, also. これと、こっち。 No response? Oh, yes. Okay, wait for the connections. Actually, you know the Osaka Expo 2025 next year. We have a expo in Osaka, yes. And then we have a collaboration with the lighting industry. So the the famous air conditioning, right? And then we will exhibit the special rooms named air traveling dining. It's coming. Need time. Doesn't working? Really? Are you sure? Right. Okay. And then we have a research collaboration with the lighting industries and the well, and then the lighting industry have the very special technologies to control the humidity and the wind as well, and then the flow type of the window. And then we have the cross-modal sensation techniques. They are integrated together to have some special meal with in an immersive way. And then the special scene, the display with a special sound and a special let's say more. This is the secret. But those things are exhibited in the Osaka Expo. Then, so what I'd like to say is that the window sensation will change our daily. So, for this expo, your meeting time will much more, right? So that the actually the windows, the condition, the situation will take us some comfortable situation and environment. So from this point of view, we are researching on this. No response. No response. You change this one? This one? Oh, back to the original one. So that is the best. It's okay. I do it.
जी लगा देना इन लोग तो लैपटॉप लगा नहीं मेरे पास तो वो है मेरा एप्पल का ही है नहीं जब तक नहीं लेके आया ना नहीं लगा तो वही लगा पहले वही लगाया था हाँ वही चला भी दूसरा लगाया मैं लेके आऊँ तो अपना
Yeah. Okay. Okay. So this is the this is just unit. Okay, we are continuing the research for this. If you have a chance to come to Osaka area, please visit our. Okay, so continue to introduce our topic. One is the multi-sensory window display system, and to overcome the previous problem, as I mentioned. So in this case, only two fans are used, but you can feel the direction of a window or an on direction. So how to realize? So we use the visual information and the audio information, right? And the visual information is showing the direction, and then the 3D sound showing it also direction. And then here we control the balance of the front and the back fan, the rotation speed according to the angle. That's all. Okay. And then this is just a result. At the top side is to have a front and the back fan, two fans on. But many participants can feel not only in the front and back, but split this direction, but 19 direction, 27 direction. No fan here, but they can feel the window coming from the right side. So this is the perception change of a window sensation using the cross-molding of audio, visual, and the window is give us some tactile stimulation. Okay, so please take a look at this. You can also check this same video on YouTube preaching using this video. So this is the image of flowing particles to display the window direction. And then if you use the headphones, you can feel the sound is rounding, rounding, round, according to the we also check the two fans, right side and the left. But we have not better result compared to the front side and back side. Maybe we guess that is coming from the ear directions and shape. Oh. Okay. あ、そうしまった。あ、そう。よし。あ、Yeah, okay. Let's do that. And then second demonstration is the strong wind sensation. And then the strong wind sensation is necessary for some kind of training for the education against the disasters or the fire accident. But if you use a very big one, very dangerous in the education situation, so how to realize the strong wind sensation without such a big one, or strong, actual physical strong one. So this is, in this case, we use also the very small one to give us a tactile sensation or pressure sensation coming from the wind. And then plus, we use the special equipment like this one. This one is the give you some sensation of fluttering when you have a very strong the wind, right? And then we investigated the frequency characteristics of the when we blow the actual strong the window to the devices, and then we reproduce the same frequency result using this. So maybe you can check here one very low frequency, 30 hertz is the main of the frequency. And then in our devices, we can also reproduce the same frequency. So please take a look at it. Like this.
Words when simulate the swaying motion of clothes caused by strong wind. Experiments with strong wind are in education or entertainment such as games. Wind describes a type of haptic device that reproduces wind, enhancing the realism of the content. However, using a powerful fun to blow strong wind across the whole body is problematic because of the size of the device and the danger of strong winds. To the compact and lightweight device induce the tactile sensation of the strong wind. When situated in a strong wind, we experience the phenomenon of our clothes covering microscope. We considered that we could reproduce the sensation of the strong wind using the tactile stimulus of the swaying clothes. We developed Horseway, which simulates the swaying clothes in strong wind by pulling strings from motors. The compact and lightweight parallel device makes it easy to experience realistic strong winds anywhere. The wind-induced intense swaying of clothing occurs in winds stronger than around 15 meters per second. We measure the vibration caused by a 15 meters per second wind and observe the peak vibration around 13 Hz. We designed the device to vibrate strings fixed to the cloth so that the cloth parts do not directly touch the cloth. Horseway comprises a cloth unit that can be worn over the arm and then actuator unit to vibrate the cloth. The actuator unit can be easily fixed to the cloth unit, and the length of the strings can be adjusted. We input a 13 Hz sinusoidal wave to the vibration actuator. When the strings connected to the cloth unit are vibrated, its waves are deformed by strong wind. We tested Horseway's ability to reproduce the swaying motion by the wind. The cloth unit swayed with a fundamental frequency of 13 Hz, the same as the input. We have designed 3 demonstrations to showcase the applications of Horseway. Users can experience the power of strong wind through the sensation of their clothes swaying. In the plant experience, the air on the plant is filled with a high sense of realism through Horseway. Horseway can be used for fictional haptic effects such as a magic battle game, as well as actual wind. The use of clothes for providing wind sensation would expand the possibilities of the wind space and virtual reality.
HMD system provides us visual information, audio information, and yeah. So you can hear the sound of the devices, but it's not effective for recognizing the strong. And then the next one is how to reproduce window sensation without wind. The last 2 scenarios are the cases using the 2 fans or 1 fan, right? But in this case, without no wind, but you can feel. So we decompose the window sensation into the multiple stimulation: visual, auditory, vibratory, thermal, and then we combine together, and then how we can reproduce the window sensation that I mentioned. And then our devices are proposed like this. In the headphone, we implemented the belt element to control the sound. information. And then we also have a vibration element to give you some the tactile kind of sensation when you feel the sound, right? And then the thermal situation is controlled like this one, and the vibration stimulation is like this. This line is just the line, the time when you feel the how to say partial wind sensation. Okay. Also, the visual and the auditory information they are given by the immersive video. Could you check this one? This is something like a otaku culture. Some kind of animation is very useful to feel wind with the video. So this blowing sound is especially important for this. We also refer to sort of things. Now we really understand how we feel the wind. One more important thing is that the user experience. You have some experience about the ear, maybe easy to feel music. And then the next is like experience winter. If you have this kind of experience, you can feel so cold when you blow with this system. But not if not, I guess it's very difficult to feel. So this is the combination in the brain. So with the experience. The experience is very important to understand or to feel such cross-modal. So next topic is the not the window sensation, but non-contact presentation of a software. And then the many of situations that use in the VR scenario. So, and then in the VR system, so maybe yesterday some topic was discussing the art. So in the VR system, we have no tactile, only a visual. So how to realize the tactile sensation in VR system? That is the our so and then this is just the importance of the tactile sensation of animal. And we are mechanical engineering people, so we invested so much what happens when you touch the bar in natural direction, the opposite, right? Using the force. So when you touch in the growth direction, the resistance force is a little bit constant, like this. But in case of the opposite side, I mean, It's okay. It's okay. It's fine. That's good. Okay. So how to produce the tactile sensation? The answer is to use the ultrasonic pump. So this is the ultrasonic devices propagate the sound to the surface of the hand. And then we control precisely the motion of the focus on focal point to produce the touching. And then plus this kind of visual information is also important to combine your the sensation in the brain, and then you finally you feel as if you touch the physical part. So this is difficult to explain. So tactile sensation. All the contents are created by our students, mechanical engineers.
The tactile experience of stroking soft fur can be enjoyable. However, the methods using real fur have several limitations in flexibility of fur properties. In this study, we present the fur tactile sensation. Using ultrasound haptic feedback and pseudohaptics,
Also, we use pseudo haptic technique.
when stroking the fur in the natural direction of growth, the tactile sensation is smooth and relatively consistent. When stroking in the opposite direction, the tactile sensation is rough and characterized by large, cyclic changes. The intensity of the ultrasound feedback is based on an air spring model representing vertical reaction force by hair compression. Additionally, pseudohaptics is used to simulate horizontal resistive force caused by the standing fur that blocks the hand movement. Specifically, control to display ratio is adjusted dynamically as the hand moves. Integrating these haptic feedback with visual representation. Various fur tactile sensations can be presented.
So small part, long part, that may be a feeling different. Those are controlled by using the physical motion, spring motion. Okay. So you know the pseudo haptics. When you move the mouse, and then sometimes the motion is slow, and then you feel some kind of resistance in your mind. This is the pseudo haptics. In this case, also pseudo haptic techniques is used to represent resistance in the demonstration. Okay. The last two are the This is the very near to the integration of sensing and this is the relaxation. This is the to control the rhythm of breath for relaxation. So sensing the stress and taking a breath, taking a rest with this device, you can recover effectively with this device. Please take a look at this. Don't fall asleep. You can see the movement of the cushion. So you can take a rest of holding this device. That's all. You don't have to train how to rest, how to control it. Just holding this. And then generally speaking, the 5 minutes to control it down to 10 hertz per 10 times per. So we are mechanical engineering stuff. Devices are inside of the cushion. Very mechanical, right? But this mechanical devices can produce software. So difficult to use to produce this kind of sensation using the data type pressure mechanical motion. In the user interface, you can also control the frequency of breath, depth of breath at the same time. Then depth, deep breath, slow breath is very effective for you. And then this is just the measurement result. So we have some phase differences, but the frequency here match to the overall signal. And then in our experiment, holding these cushions on your stomach is the best way to control your heart. So other parts are not effective. So maybe you feel like this cushion is your own stomach. That's why you can control smoothly and naturally. Okay, I speak this one. The last one is the sensing in augmentation. Just take a look at this. In my introduction, the sensing and augmentation, they are separate. But in this case, the augmentation is no, sensing is augmentation is okay. So in this case, I'm using the activity, but the kind of the immersive maybe sensing is should be done in the augmentation or at some time and same kind of the situation. So how to install those kind of sensing system in augmentation and how to feedback what kind of information. This is the problem. Okay, so maybe near future the system where games will interact to our internal state or mental state, so that virtual reality system is much more upset. Huh? Okay, so this is just summary that the for well-being, the sensing and the augmentation are combined together in our daily. And then how to change or change the active work and effectiveness. This is the very important for us. And then we also have the brain time, meeting time, and sleeping time. So how to move to the each state, supporting the sensing technology and augmentation to realize the say the better life. Effect. That is my how to say that's what I like to say. Thank you very much. The Professor Yuki Pan, maybe next time I'll come with him. He's the one of the leading researchers across models. Thank you very much. Any questions? Any questions? Thank you.
There's one question there, ma'am. One from back also.
Maybe next time I will come with this some of it so that you can see.
Sir, please explain the orthogonal control one more time, like how you are using the VR headset for like with heart rate and with chest. In the last you have shown right, heart rate and with chest. The
So
VR
please start again. I cannot. But I please use mic.
the virtual reality glasses which you have shown, the last video, there you have showed with chest and heart rate you were controlling, right?
Yeah.
So that thing was is in one moment. Like, how it is done.
In the last demonstration.
Yeah.
Okay. So the knowing the internal state or stress state of the brain, the VR system can change its behavior and context according to the user brain. That is the so in this very scare horror games, sometimes too much situation. So the players don't like that. But if the system knowing how they are feeling to the game context, they can adjust their color level or difficulty levels according to not only the performance but also the interaction. That is what I think.
These are same
Just curiosity. The one thing is that this below breathing, like for dealing with breathing problems, cushion, you take cushion. So there are patients which have arrhythmia they suffer from rhythm.
Copy paste
There is a change in rhythm, and that becomes a threat to their life also. Have you also experimented with those types of patients which suffer from arrhythmia?
Engineer.
Rhythm, arrhythmia. That means the rhythm is actually disturbed. Heartbeat is rhythm of heartbeat.
Heartbeat.
Yeah.
In this case,
Cushion. Cushion.
cushion. Cushion. There are cushion.
So those whose heartbeat
Change.
controlling the rhythm of breathing. So patients suffer from arrhythmia for a long time. That can be life-threatening as well. My question was, have we experimented with those patients?
No.
We have not. Yes.
Okay.
Okay. This could be a very good device for those patients who suffer from arrhythmia.
Yeah.
And so I believe that Professor Gupta, Professor Tandon, they can collaborate with you to find out some suitable doctors here. And if we can, if patients agree, then we can apply them on people suffering from arrhythmia. Yeah, one patient is with me also, so I know that. It's a very life-threatening. Second is this wind sensation. Well, you have used it for well-being. I was curious about what if that is exposed too much. So sometimes if I'm feeling cold because of wind sensation, we say in India that mind controls everything, and therefore you may feel good if your mind is good. If suppose too much of wind sensation I am feeling for cold, do I also exhibit symptoms of cold and cough? Have you experimented with this?
We have no experience such, but you're right. So it's some, so maybe our experience is agree to that opinion. Actually, the same condition we had to say, but I have no English word, but accustomed to this situation. So no feeling. So we need some change. So motivation this the research is natural way when you open the window, very comfortable. How to reproduce this kind of comfortability using this? That is the first, but still very difficult to reproduce the fresh air when you open. And then that's why. So the same condition, maybe you are get used to it, and then you don't feel it. So maybe the how to display this using this technique, not the technique itself. It's the powder of
Opposite of what?
yeah.
You're thinking for well-being. I'm thinking about validating this idea that mind controls body.
Mind control. I don't like that one.
What is happening actually?
Maybe well-being. This is my the opinion. Change is very. If you always relax, is it okay? Maybe sometimes exciting.
Have provided us with new insights and a deeper understanding of the subject. We sincerely appreciate your valuable contribution to the work. Sorry for the inconvenience caused. Now I'd like to invite Professor Puneet Tandon sir for presenting memento as a token of appreciation as well as certificates to Professor Shinichi Vatsa.
Let's start the research collaboration with this technique or this technique.
Professor Tanuja Shivde will be presenting the same.
very important. Yeah. Sure. This is most important. Special process.
Yeah.
Is it?
You might have been brought back with the voice. Might have been brought back. Yes, EMF 100%. 100%.
What is the second back?
Used to come like
Brother.
You can also come.
Your next speaker.
Yeah.
If I'm taking my lecture here. Oh, really? Thank you.
She's invited us.
Thank you so much.
So, please have a fast tea. We'll have to start the next session at sharp 3:30 p.m.
Thank you.
Quick.